So the next topic is relative permittivity or dielectric constant or specific inductive capacity or dielectric coefficient. The dielectric constant or relative permittivity or specific inductive capacity or dielectric coefficient is given by the ratio of absolute permittivity of the medium to the permittivity of free space. Epsilon r is equal to epsilon by epsilon naught. The dielectric constant or relative permittivity or specific inductive capacity or dielectric coefficient can also be defined as the ratio of electrostatic force between two charges separated by a certain distance in vacuum to the electrostatic force between the charge separated by the same distance in that medium. Epsilon r is equal to fb by fm. Dielectric constant has no unit. The next topic is continuous charge distribution. Any charge which covers a space with the dimensions much less than its distance away from the observation point can be considered as point charge. A system of closely spaced charges is said to form a continuous charge distribution. It is useful to consider the density of charge distribution as we do for the density of solid, liquid and gas. So let us consider the first topic, that is line or linear charge density, which is otherwise noted by lambda. If the charge is distributed over a straight line or over the circumference of the circle or over the edge of the cuboid, etc., then the distribution is called as linear charge distribution. Linear charge density is the charge per unit length and the SI unit is C by meter. So lambda is equal to Q by L or lambda is equal to dQ by dL. So the total charge on line L is given by Q is equal to lambda into dL. The next topic is surface charge density, which is noted by sigma. If the charge is distributed over a surface area, then the distribution is called as surface charge distribution. Surface charge density is the charge per unit area. Its SI unit is C per meter square. Sigma is equal to Q by S or sigma is equal to dQ by ds. So total charge on surface S is equal to sigma into ds. So the next topic is volume charge density, that is noted by the letter rho. If the charge is distributed over the volume, then the distribution is called as volume charge distribution. Volume charge density is the charge per unit volume and the unit is SI unit is C per meter cube. So rho is equal to Q by R rho is equal to dQ by dr or Q is equal to rho dr. So this is all about the continuous charge distribution. The next topic is electric field. So electric field is nothing but let us consider the example in a cricket ground. So field is nothing but the boundary where the boundary in which a charge experiences an electric field. So in physics we call it as electric field is a region of space around a charge or a system of charges within which other charged particles experience electrostatic force. Theoretically, electric field extends up to infinity, but practically it is limited to a certain distance. So next topic is electric field strength or electric field intensity or electric field. Electric field strength at a point in an electric field is the electrostatic force per unit positive charge acting on a vanishingly small positive discharge placed at that point. So let us consider a positively charged and a discharge which is coming near to the positively charged. The discharge is considered to be vanishingly very small because its presence should not alter the configuration of the charges and thus the electric field which is intended to be measured. The formula of electric field is given by E is equal to F by Q, where E stands for electric field, F stands for force and Q, which means here we are having two Q's, so delta Q. Okay. So delta Q is nothing but Q2 minus Q1. Here we are having source charge and test charge, and the formula of electric field is given by 1 by 4 pi epsilon naught Q by R square R cap. Okay, So this is all about electric field, and you have to note this certain points. Q naught should be taken positive. The direction of electric field is along the direction of electrostatic force. Electrostatic force on a negatively charged particle will be opposite to the direction of electric field. Electric field is a vector quantity whose magnitude and direction are determined, and the SI unit of electric field is Newton by Coulomb minus 1. So